Good evening, everybody. Welcome to today's lecture on Introduction to Statistics Part 2. Uh, Hi, is everybody around? Can everybody hear me loud and clear? Yes? Okay, great. I've got a yes from Parth. I got a yes from few others last time, so that should be good. And just a quick check. Can everybody see me scribbling something with the red pen on the screen? Yeah? Great. Great. All right. So guys, before we move into the lecture, let's just do a quick refresher on what we covered last time. All right. Uh, we started with our information pyramid. Okay. We talked about types of variables. Then we got into the concept of random variables. Post that, we talked about how do we really describe random and variable components of random variables. So we said for defining the variable, we need, what are the two things which are required for describing a variable, guys? Can somebody tell me? Measures of we said measures of central tendency and measures of, anybody, any guesses? Very good path. We said measures of central tendency, measures of dispersion. Okay. And we said that, you know, the random variable, the random component can be defined using probability distribution functions or probability density functions, right? Can anybody make a guess or can recollect that what do we mean by probability distribution or density function? What do we mean by that? What is a probability distribution or a density function, guys? Do any of you remember? Or you want me to repeat? A value assigned to each value is what Deepak is saying. Okay, Parth says for defining value of probability. Okay, okay. Any other guesses, anybody? Okay, let me just quickly, you know, make you guys recollect what exactly a probability distribution or density function is. We said that in a random variable, there are two components. One, that the variable should have multiple values. And for each of the value, there should be a probability associated with it. So for example, if I'm talking about number of students in a class, and let's say there can be 50, 51, or 52 students, and I'm saying that the probability of having 50 students is 0.4, 51 students is 0.3, and 52 students is 0.3, then this is a random variable. A mathematical formula which helps me identify the probability associated with each of these values is what we call as a PDF, or a probability distribution function. Everybody remembers that? Yep. I'm hearing yes and yep only from Deepak and Parth. What about others? Srinivas is also convinced. Kirti is also fine. Great. Great. So guys, as I mentioned that, okay, let me just probably move on to the Word doc for everybody's simplicity. So guys, what I'm saying is that a probability distribution function is a mathematical formula, okay, which helps you define the probability associated with various values which a random variable can take, right? And then we talked about the difference between probability distribution functions and probability density functions, right? And I very well understand that there were a few queries which I received from Parth. Parth, I'll respond back to you on those queries in the email itself. So don't worry. After the class, I'll respond back to your queries. All right. Okay. So guys, we also mentioned that the probability distribution function is for which kind of variables? Discrete or continuous? Okay, Kirti says discrete, Parth also says discrete, Deepak says continuous. What about others? Dilip says discrete, Ramesh. Okay, so guys, probability distribution function is for discrete variables, okay, whereas probability density function is for continuous variables, okay. So guys, let me just do another quick check on if you guys still remember it or not. So let's say I have a variable x which can take value 1, 2, 3 and 4. Let's say the probability associated with value 1 is 0.1, with 2 is 0.2, with 3 is 0.3. What will be the probability associated with value 4? Quick guess. Parth says 0.4, Deepak says 0.4. What about others? Everybody's convinced with 0.4. Why can't it be 0.3, guys? Very good, Deepak. It can't be 0.3 because sum of all the probabilities for a variable should be 1, and we are just left with 0.4 of probability, and this is the only value left, so 0.4. Okay, part we are not talking about linear relationships here. Okay, it's a very basic probability funda that if there are 4 variables, the total 4 values which a variable can take, then the total probability associated with all the 4 values together will be 1. So it is 0.1 plus 0.2 is 0.3, 0.3 plus 0.3 is 0.6. We are left with 1 minus 0.6, that's 0.4. Everybody clear on this? Great, perfect. Now let's quickly look at the probability density function. We said the density functions are for continuous variables. So let's say if I have a variable x which is a continuous variables, how many values can it take, guys? A continuous variable x, how many values can it take? Very good, infinite number of values. So can I say that the probability associated with each of these values will be multiple number of lines out there? Can I say that? Yep. Okay, and if there are multiple values, and when we talk, can I just join them with a straight line, all of them, because they're infinite and there's not going to be any space in there, they'll be all filled up like this? Yeah. So guys, in case of continuous variables, are we concerned with range of values or absolute values? What are we concerned with? Range of values. Very good. So if I have to find out the probability for a range of values, let's say between this and this, between these two ranges, what will be the probability associated with it? Can I say all the lines between these two values? Can I say that? Yes. So if I consider this as a curve, can I say that the area under this curve is the probability which I have to be concerned about? Yes. Parth, I hope this answers one of your questions. Yeah. Okay. Now guys, tell me, if I have to find out the probability for the range of values starting this beginning till this point, and it turns out to be 0.9, what is the probability for value greater than this particular value? Everybody? Perfect, perfect. 0.1. Because the total probability can be at max 1. Very nice, guys. Good. So I think all of you understand of what we have talked about. Parth has a doubt. Every time area sums to 1? Yes, Parth. Every time. Every time. Okay? Great. All right. So guys, today we will talk about one of the most commonly used probability density functions, which is used for continuous variable, normal distribution. Has anybody heard about normal distribution before? Yes. Has everybody heard about it? Okay. When do you really hear this distribution a lot? In which case do you hear this distribution a lot? Yeah, appraisals. General application, Himanshu. Okay. For all those guys who have been into corporates, people also call this normal distribution as bell curve. Okay. And they use this kind of a curve a lot during the appraisal discussions. Yep. So guys, when we say a normal distribution or a normal density function, a normal distribution or a density function is a mathematical formula. This is the mathematical formula which helps you identify the probability associated with the value or with the range of values. With the value or with the range of values, guys. Okay. Why range of values? Why range of values? Because the normal distribution or the normal density function is only there for continuous variables. Very good, Parth. Yes. Okay. A normal distribution is only defined for continuous variables, and therefore this mathematical function helps us identify the probability over the range of values. Okay. So let's do one thing. Let's try and understand that what this function is all about. Okay. Now guys, tell me, everybody understands this symbol? Pi. Is this a constant or a variable? Very good. It's a constant. What about E? What is this? Deepak has a question. Distribution function is for discrete and continuous function is density function is for continuous. Yes, Deepak. Yes, that's true. Okay. So E is exponent. Is it a constant or a variable, guys? Guys, exponent is a constant. Exponent is a constant. You can check it online, Google. Exponent always has a constant value. Okay. It is not a variable. Is everybody clear on that? Okay. Uh, I think Deepak has a question. Deepak is asking, isn't normal distribution, Deepak, yes, people always use density function and distribution function inversely, interchangeably. Okay, so you can call it a distribution function, but the right terminology to use is density function. Okay, great. All right. So what I was saying is that pi is a constant, e is a constant, 2 is a constant. Yes. Yes, guys. 2 is a constant. Now this x is nothing but a range of value for which we have to find out the probability. Okay. So then it means the x is also known to us. Can I say that? Yes. So for example, if I have to find out the probability of a variable holding values between 2 to 3, I know that I have this range available with me. So I have the value of x available with me. So guys, what is not available with me in a normal distribution is mu and sigma. Can I say that? That everything in this function is available with us except mu and sigma? Right? So can I say that my normal distribution function is dependent on two values, mu and sigma? And once I have mu and sigma, I can find out the probability for any range of values. Can I say that? Perfect. Now, can somebody tell me what is mu? Mean. Absolutely. Absolutely correct, guys. Mu is mean. Okay. And what is sigma? Very good. So what we are trying to say now is that in case there is a variable which follows normal distribution, and if we know about that variable's mean and standard deviation, then we can find out the probability associated with the range of values which this variable can hold. Can I say that? Yes. Guys, you want me to repeat the statement? Should I repeat the statement, guys, or are you all comfortable? Okay. Okay. I think there are a few repeat requests. Guys, what I'm saying is that if there is a variable x, uh, sorry guys, I think something's wrong. Just give me 1 second. It's saying that I've logged in from another device. Uh, yeah, all right. So guys, I think we're back. Yeah, all right. So what I'm saying is, guys, that let's say if there is a variable which follows normal distribution, okay, and we know about the mean and the standard deviation of that variable, okay, then it is possible for us to find out the probability associated with the range of values which this variable can take. Is it clear now, guys? Yes, Ashima, Srinivas? Okay. So guys, as I mentioned, that this is a probability density function. Now, if I have to find out, okay, Ashima is saying I didn't understand probability associated with range of values. Okay. Ashima, let's say there is a variable x, okay? Yes, I'm just giving an example. Let's say there is a variable x which can take any value from 1 to 1000, okay? Let's say it's a continuous variable. Now, I want to find out the probability for X to take values between 3 and 5. Okay, so I want to find out X to take any value between this range of values, that is 3 to 5. What is the probability that X can take any value between 3 to 5? In order to find out that probability, if you know the mean of X and the standard deviation of X, then using this formula, you can find out that probability. Ashima, does this make sense? No, I just gave an example that that X can take any value between 1 and 1000. You know, mean or max, even if you don't know, doesn't matter. What you need to know is only the mean and the standard deviation. Minimum maximum will not help, because this probability calculation formula only requires standard deviation and mean values. Guys, is everybody clear on that? If you have any doubt, please ask me right now, because it is the basis of any normal distribution calculation. Great, great. Okay, so guys, now if I have to find out the probability for a variable to hold values between 3 to 5, this is a continuous variable. No, Deepak, don't worry. I'm just coming on to that. Okay, you don't have to worry about learning this formula. We said that this is a probability density function. So guys, in order to find out the probability, what needs to be done? It has to be, we have to find out the area under the curve between this range. Yes. Remember when we showed the continuous variable, we said if this is the range for which you have to find out the probability, you have to calculate area under this curve. Yeah. How do we calculate area under the curve, guys? Anybody remember 10th class? Okay, good. A lot of you remember 10th class mathematics. Yes, we have to do integration over the range of 3 to 5. So if you'll integrate this formula for the range of 3 to 5, you will get the probability for that variable to hold values between 3 and 5. Now, how many of you would want to do an integration? No? Okay. So guys, definitely there is no need to muck up this formula or to do integration, okay? Because we now have tools and technology available which can help you in doing this kind of a calculation, with a simple function, okay? So let's look at how we can do it in Excel. All right. So let's try and do it in Excel. All right. So guys, what I've done is I have got the height of male population in US. Okay. So I've got a sample which tells me the height of male population in US. All right. So if you look at it, these are the various heights of male population in US in inches. So starting from 60 going till 82. Okay. So if this is the sample data which I've collected, so let me just make a few terminologies clear here. What I'm saying is that there is a random variable height of male population in US. Okay, it's a random variable. This random variable has got multiple values, 60 inches, 61 inches, so on and so forth. Okay. The average value for this variable is 70, and the standard deviation is 2 inches. Okay, is everybody clear till this point? That we have a random variable that is height of male population. No, okay, Deepak is saying average is 71. Deepak, I'm not taking the average of this values. These are just sample values. I'm saying that the average height is 70. Yes, Himanshu, average height is mean. Okay. So guys, I have got a random variable for which I'm being given that the mean height is 70 or the average height is 70 inches. The standard deviation is 2 inches. Soumya, assume that it is being given. Okay, assume it is being given to you. All right. Even if it is not given to you and you have the data set, you can always calculate it, right? The way we did it last class. You remember we calculated variance and standard deviation in the last class? Okay, if you don't remember that, you can always refer back to the last class video and you'll get to see how we calculate it, all right? But for now, let's assume that we've been given the mean and the standard deviation for height of male population in United States, all right? So let's try and find out that what is the probability for a US male to have the height less than 65 inches. Guys, is the question clear to everybody? Yes? So we are trying to find out the probability for this random variable to take the value from anything starting from 0 to 65. Deepak, it's not 60 to 64. As I said that this is just a sample formula. I'm saying, okay, the minimum height, you know, could be somewhere around, let's say 1 feet or let's say 2 feet. I'm not sure. Okay. So whatever the minimum height is, that till 65 inches. Okay. Okay. So Parth has an interesting question. Parth is saying, is 65 inclusive or not? Okay. So Parth, let me ask you a series of questions and then you'll be able to answer it yourself. Guys, everybody understands what Parth is asking? Parth is saying that if we are calculating the probability from some value to 65, so is 65 included or not? Okay. Okay. Parth, I want you to answer these questions. Okay. When we calculate probability for a continuous variable, we do it over range of values or absolute value? Range of values, very good. And when we calculate it over range of values, how do we do it? We calculate area under the curve, right? Or do we do it differently? Yes, area under the curve. Now let's say if I don't have a range of values and I just have a single value, what will be the area under this single value? Parth, will there be any area under a single value? No area, right? Exactly. So if I say that I want to include 65 from a continuous variable perspective, is there any probability associated with single value 65? A single value 65, will it have any probability? No, right? Yes, if somebody says 64.9 to 65.1, yes, definitely there is a probability. But individual 65 will not have any probability. Okay, so when we are calculating the probability for this range of value, we are saying anything from the starting point till 65. Till 65. Okay. Is this clear to everybody? Parth? Yeah? Others? Everybody? Great. Perfect. Perfect. If this is clear, so then let's move ahead. So what I'm trying to do now is I'm trying to calculate the probability for a male to have height less than 65 inches. All right. So guys, how do we calculate a normal distribution probability? There is a function in Excel with the name norm.dist. Guys, remember this function norm.dist. Okay. Norm.dist take 4 arguments. The first argument is the limit till which you want to find out the probability. Okay. So in this case, I want to find out the probability till 65. So the limit over here is 65. That's going to be the first argument, 65. The second argument is the average or mean for that particular variable. So what is the mean height, guys? What is the mean height? Very good. That's 70. The third argument is standard deviation. What is the standard deviation given to us? 2. Very nice. And the fourth argument is that whether you're looking at a cumulative probability or not. So guys, this is one thing which you have to remember always, that whenever we are talking about normal distribution, we are only looking at cumulative probability. Okay. So we will always give the fourth argument as 1. Okay. Everybody? Exactly, Deepak. Cumulative means up to 65. Right. But cumulative means that you're not looking at any standalone value. You're looking at a range of values. That's what cumulative means. Okay. Since we always talk about range of values, we always have to give cumulative as 1. All right. And then you close the brackets. And here is the probability. Kirti, this is just a flexibility which is being provided with the function. Okay. From our analytic standpoint, we don't have to worry about false option. Okay. Himanshu is asking, so what was X? Himanshu, X is the limit till which you have to find out the probability. So in this case, we have to find out probability till limit 65. Okay. So that's what X was. X is 65. Does this make sense? Okay. So guys, this means that the probability of a US male to have a height less than 65 inches is just 0.00621. Okay. So guys, will you guys do just one problem for me in the class itself? Yep. Okay. I want you guys to find out the probability for a US male to have height greater than 75. Find out the height of US male, find out the probability for a US male to have height greater than 75 inches, given that the mean height is 70 and the standard deviation is 2 inches. It's 8:07 in my watch. I'll wait till 8:09. You have 2 minutes to calculate it. Deepak, I'm talking about height greater than 75. Greater than 75. What is the probability? Okay. So Deepak is saying 0.00621. All right. Himanshu is saying 0.993. Okay. What about others? Ashima is saying 0.62. Dilip is saying 0.00621. Okay. All right. Okay. So if everybody has tried that out, should I show the example answer, or you guys need another minute for those who are calculating? Okay. So let me just take you through the answer. Okay. Just give me 1 second. Deepak is saying 0.993 is the probability up to 75. Greater than 75 will be 1 minus 0.993. Very nice. Okay, that sounds pretty nice. Okay, so let's see, guys. When we calculated probability till 65 inches, we said that the function takes the value till the upper limit. So the probability which it gave was everything below 65. Now what I've asked for is the probability for the variable to take value greater than 75. Now, are we aware of the upper limit for this range? Are we aware of the upper limit? No, right? But given the formula, can I calculate the probability below 75, because 75 is the upper limit which I'm aware of from this particular area standpoint? Yes, can I do that? So if I'll key in 75 into my formula, what I'll get is the probability below 75. Everybody clear till this point? Yes. And what we have to calculate? The probability for height greater than 75. So if I'm aware of probability below 75, what will be the probability greater than 75, guys? Exactly. Very nice. Very nice, Dilip. Very good, everybody. So that's what I wanted to hear. So let's quickly calculate it for everybody's benefit. What I'm saying is we use norm dist. Over here, x is 75, mean is 70, standard deviation is 2, cumulative value, as I've said, we'll keep as 1. So this gives me the value of less than 75. But since my target is to calculate the probability of greater than 75, I'll do 1 minus this value. That's 0.00621. Is everybody clear on this, guys? For those who have calculated, that's absolutely fine. For those who haven't, is everybody clear? Perfect. Now, if this is clear to everybody, can can all of you quickly calculate one more probability for me? Yeah? Will you do it? Okay. Tell me that what is the probability for a US male to have height between 68 inches and 72 inches? Between 68 inches and 72 inches. It's 8:12 in my watch. We'll wait till 8:15. Okay? And I'll wait for the answer. The mean and standard deviation remains the same. We want to find out the probability for a US male to have height between 68 and 72 inches. Okay, so Deepak is saying 0.682. That was pretty quick. What about others? Okay, Himanshu is also saying 0.6826. We have 2 more minutes. Parth has also come up with the same answer. All right. Srinivas also, Ramesh also. Pretty good. Perfect. So I think all of you have got certain answers. Now let me do it for those who haven't calculated it till now. I think almost everybody has done that. So guys, what we have to do is we have to find out the probability which is between 68 and 72. So can I say that we will first calculate the probability less than 72 and subtract from there the probability which is less than 68, and then what we'll be left with is the probability between 68 and 72. Can I say that? Yes? Okay. If I can say that, then let's calculate it. What we are saying is equal to norm dist. Let's compute the probability for 72 first, comma mean is 70, comma standard deviation 2, cumulative always 1. So that's 0.84. Then let's compute the probability for 68. That's equal to norm dist 68, comma 70, comma 2, comma 1. So that's 15.8%. And the subtraction of these two, 682,689, that's the probability. Everybody clear, guys? Yes? Okay. So guys, till now, what we were doing is we were making use of this formula to calculate the probability. Okay. But is there a better way to do it? You know, some standard numbers which we can remember or something like that. Okay. So guys, there is a rule which I'll talk about now, which will help you identify certain standard probabilities very fast. Exactly, Dilip. So the rule is 68, 95, Dilip, is it 97 or 99? 99. So it's 68, 95, 99 rule. Okay. What this rule says is that if you are one standard deviation away from the mean, okay, so let's say if 70 is my mean and 2 is my standard deviation, and if I'm one standard deviation away, that is one standard deviation away from 70 is 72 on this side and 68 on this side, okay, then the probability for this range of values, that is from 68 to 72, will be 68% or 0.68. Guys, everybody clear on what I've said, or you want me to repeat? Okay, I think a few of you want me to repeat. Let me do that. Guys, what I'm saying is that if I move one standard deviation on either side of the mean, okay? So if my mean is 70, then what will be on the right hand side of one standard deviation? 70 plus 2, 72. And on the left hand side, 70 minus 2, that's 68. Okay. So for this particular range of values, exactly Himanshu, we can say that. Okay. So guys, what I'm saying is that for the variable, the probability for that variable to take this range of values is 68%. Which means if I have to, say it in terms of the problem which we were solving, the probability for a US male to have height between 68 and 72 inches is 68%, because 68 and 72 are one standard deviation away from my mean. Is this clear to everybody, or you want me to repeat? Soumya, is it clear? Great. The next point to that rule is after 68 we have 95, which means if I have to find out the probability for a US male to have height 2 standard deviations away from the mean, that is between 66 and 74, because 66 and 74 are 2 standard deviations away from 70. So the probability for the US male to have height between 66 and 74 is 95%. Is this clear? Okay. And the third level of this rule is 99, which says that if you are 3 standard deviations away from the mean, the probability will be 99%. So in our case, the probability for a US male to have height between 64 and 76 is 99%. Everybody clear on that? Yes? Perfect. Perfect. Great. So now if everybody is clear, let me ask one or two quick questions for which you should be answering me back in just 2 or 3 seconds. Okay. The average score of a student in statistics is 50 and the standard deviation is 5. What is the probability that the student will score between 40 and 60? What is the probability for the student to score 40 to 60 marks? Very good, 95%. What is the probability for the student to score 45 to 55 marks? Very good, guys. What is the probability for the student to score 30 to 70 marks? 99%. No? Guys, how 99%? Guys, the standard deviation is 5. Yeah. So it has to be between 35 and 65. 30 and 70 were exactly, Deepak. They were 4 standard deviations away. Okay. So don't get carried away. That was just a trick one at the last, just to bring you guys into the flow. But that's okay. But I hope all of you understood the concept. Yeah. Has everybody understood the concept, guys? Perfect. Great. Great. All right. Okay. Guys, what we have just now calculated, Parth is saying how 35 to 65. Parth, my average was 50 and my standard deviation was 5. So what is 3 standard deviations away from 50? That's equal to 50 minus 3 star 5. That's 35. And similarly, 50 plus 3 star 5. That's 65. Parth, are you clear? Yeah. Okay, great. So guys, what we have just now talked about is also called as the confidence. We also call it as confidence. Now, why confidence? Any guesses? Why do we call it as confidence interval? We call it as confidence interval because, let's say in my last example of 35 to 65, you were 99% sure that a student will get marks between 35 to 65, right? You were 99% sure, right? So if tomorrow somebody comes and asks you that, so let's say, uh, I go to Parth and ask him that, Parth, what do you think the students can score in today's maths exam? And Parth tells me that, sir, I'm 99% sure that students will get score between 35 to 65 because in previous exams they've got an average of 50 and a standard deviation of 5. So that tells me that Parth is 99% confident, right? Can I say that? Guys, you want me to repeat? Guys, do you want me to repeat? Everybody is clear? Great. Because it is talking about the confidence which you guys have. That's why the range of values for which we are finding out the probability, we call these range of values as confidence interval. Okay. And the probability associated is called as confidence level. What confidence level you have for this confidence interval? Okay, guys, is the terminology clear? Perfect. So guys, now tell me the confidence level for the student to score 45 to 55 marks. If I have the mean score as 50 and standard deviation as 5, what is the probability for the confidence interval 45 to 55? Perfect. The confidence level for confidence interval 45 to 55 is 68% or 0.68. Guys, everybody clear on that? Yes? Great. Perfect. All right. Now, if everybody is clear on that, ouch. Yeah, Himanshu has a question. Tell me question. Tell me, Himanshu, what is the question? Why are we considering 68, 95, 99? Okay. Himanshu, if you would have realized, oh, why are we considering 68, 95, 99 for one standard deviation, two standard deviation, and three standard deviation? No, no, no. Okay. Himanshu, we are not considering anything. Okay. Even if you'll do the calculations, you'll get this probability. Okay. So for example, let me do it quickly for you so that it clears it out. You remember we talked about this US height example, male population height. The mean is 70 and the standard deviation is 2. Okay. So what is the confidence interval, one standard deviation on both sides? Tell me quickly the confidence interval. That's 68 to 72. Okay. Let me calculate the probability within this range. So is equal to norm dist 68, mean is 72, 1. Similarly, norm dist 72, 70, 2, 1. And the subtraction of these two minus this. So you see, this is approximately equal to 68.2. Yeah. If you'll go with two standard deviations, that's 66 to 74. You see, this is approximately equal to 95%, 0.95. And similarly, 64 to 76. You see, 99% approximately. Yep. Guys, is this clear to everybody? That why we are considering 68, 95, 99? Perfect. Perfect. Okay. So guys, till now, what we were doing is we were being given a range of values and we were being asked to find out the probability associated with that value, right? Yes, that's what we have been doing, right? Great. What if in a real-time scenario, somebody comes and asks you that I want to be 99% confident to find out the height of the US male population. Tell me, what is the confidence interval? Okay, so guys, there are two different things now. In the first case, we were being given the range of values and we were being asked to find out the confidence level. Now I'm being given a confidence level and I'm being asked to find out the range of values. Okay. Okay. So guys, okay, hold on to that. Uh, First of all, I have not given you the question yet. I'm just telling you that there can be a question like that. Okay. And now we will see how do we really find out the probability using Excel. Parts Ramesh, 35 to 65 might work well if we are talking about the mean being 50 and the standard deviation being 5, right? But that will not be the case all throughout. Your mean and standard deviations might change. Okay. So let's try and find out. Let's assume our US male population example only. Okay. The formula to find out the range of values, guys, okay, is norm dot inv. What is the formula? Norm dot inv. What was the formula for finding out the probability, guys? Norm dist. Exactly, Deepak. The formula for finding out the range of values is norm dot inv. Okay. Now, the first thing which this formula asks for is the probability you're looking for. So what is the probability I'm looking for, guys? 0.99. What is the mean value, guys, for the male population? Mean, average, 70. And the standard deviation is 2. So once I'll feed it in, I get the value as 74.652. Okay. Now, guys, can somebody tell me if okay, just give me 1 second. Let me draw 3 regions out here. One is this region. One is this region. And the other is 76, 260. One is this region. So the first region which I drew was, let's say, A. The second one is B. And the third one, which is between 64 and 76, is, let's say, C. Which region has the formula picked up? Was it A or B or C? A is anything below 74.6527. A is anything below 74.6527. B is anything above 74.6527. And C is anything between 64 to 76. So which one has the formula picked up? Okay, so Deepak says C. Dilip says A. Ashima says A. What about others? Ramesh says A. Parth says C. Okay. What about others? Kirti says Kirti didn't get the question. Okay. Kirti, what we have just done is we tried finding out the range of values for us to be 99% confident. Okay. Excel gave us the value 74.6527. Now my question is that the probability which is getting calculated. So Excel has given us a value over here, 74.6527. What I'm asking is that the probability which Excel has calculated, is it the complete area below 74.6527? That is, all of this? Or is it the area above 74.6527? Or is it the area between 64 to 76? What is it, guys? Tell me. Kirti, is the question clear now? Okay, so Deepak has changed his stance to A. Kirti has got the clear question now. Parth is saying below. Parth, did you mean A? Okay. Soumya and Kirti are saying it is the area between 64.76. All right. So I think I've got answers from most of you. Yeah. Yes. Yes. Okay. Great. So guys, if you remember, when we calculated the probability for range of values, we said that the probability is being picked up till the upper limit. Remember, everybody? Soumya, Kirti, yeah? Okay. Now, when I'm giving a probability and asking Excel to find out the range of values, will it give me the upper limit or certain thing between the confidence intervals? I'm just doing the inverse. It will give me the upper limit. No, Deepak, it will give you the upper limit. When you give him upper limit and try and find out probability, it gives you value till upper limit, right? Now, if you know the probability, it will obviously give you the upper limit, right? Exactly, guys. So guys, whenever we try and provide the probability, we have to make sure we are providing the probability till the upper limit we want to find out. Okay, is everybody clear on that? Yeah. All right. Now I think I have a few questions which we can look at. All right, here we go. Estimation. Okay, let's look at this one a little later before I'll explain a few concepts, I think. Okay. All right. So guys, is everybody clear on what is a normal distribution? Yes? Can you guys quickly try and help me find out the probability for yes, Ashima, that's true. So what Excel told you is that the probability that for you to be 99% confident, a US male population can have a height of less than equal to 74.65. Okay, great. Guys, can you quickly tell me the range of US male height for you to be 60% confident? Ramesh says 70.77. Okay. 70.93. Okay. Quickly, guys, norm inverse 70.50. Everybody's getting different value. What happened? %60 confident. Yes. So guys, what we're doing is norm inverse 60% confident. Okay, not a problem. Mean 70 and standard deviation of 2. So we get 70.50. Perfect. Perfect, guys. Great. All right. That's absolutely perfect. Now, should I go ahead? All right. Let me just explain you one more concept of Parth is saying repeat. Okay, Parth, what I asked for is for you to be 60% confident in finding out the height of US male population, what range of height should be picked up? Okay, so you have to be 60% confident. I said norm inverse for 60% we are saying 0.6, mean is 70 and standard deviation is 2. That means the range of values should be 70.5. Okay, all right, great. So guys, if you have understood this, let me just go a little more into deep and explain you one more concept on normal distribution. Okay, so guys, let's say this is the distribution of US male height. Okay, now let's say I have a similar distribution, but this is for the weights of US male population, let's say. Okay, this is for the weight of US male population. Now, and let's say the mean weight of US male population is 70, and let's say the standard deviation is 5. Can you compare these two distributions is my question. Can you in any way compare these two distributions? No? Why we can't compare it? Exactly, Deepak. There are different units. The one which we talked about earlier was having a units of inches. The other one is having the units of kgs. Yeah, both are having bell curve. That's absolutely okay. But will you be able to say that whether height is more distributed than weight or not? Can you say that? No, right? So is there a way we can really start comparing two distributions? Is there a way to do that? No, guys, no. We're not talking about correlations here. We're not talking about correlations here. I'm talking about the distribution of variables. Okay, not the correlation of variables. The way to compare two normal distributions is by removing their units. If let's say I would have done some kind of a mathematical calculation on these two distributions so that their units would have gone away, then could I have compared these two distributions if they are both on the same units? Yes. Right now, this one is inches and this one is weight. What if these two units will go off? Then I'll be confident, right, that I can compare these two distributions. Yeah. Now, in normal distribution, yes, Deepak, there is some kind of a division, some kind of a subtraction required. Guys, the way to do that in normal distribution is what we call as Z statistics. Okay, we calculate Z statistics which standardizes all the distributions. Okay, and how to do that? From each value the variable can take, let's assume it to be X. You subtract from X the mean value of the variable, that is the mean of x, okay, and divide this particular subtraction by standard deviation of x. Okay, guys. So what I'm saying is that the way to calculate Z statistics is from each value of x, you subtract mean of x and divide this subtraction by standard deviation of x. Okay, so let's take a few values. Let's say if the mean height was 70 and standard deviation was 2. Okay, so for the height 70, what will be the Z score? For height 70, what will be the Z score? That will be equal to height 70 minus mean of height. What is the mean value of height, guys? 70, exactly. And you divide both of them by this standard deviation, that is equal to 2. So the Z value comes out to be 0. Guys, is this clear to everybody? Guys, did you notice one thing? That the mean value, the Z score of mean value is 0. Exactly. The Z score, the Z score or the Z statistic for the mean value is 0. Okay. Now can somebody quickly calculate and tell me that what is the Z score for height 72? Srinivas is asking, will it be inverse bell curve? No, no, no. It has nothing to do with the bell curve, Srinivas. Okay, yeah. All right, good guys. So the value is 1. What is the Z value for 74, guys? Very good. Bell value, oh sorry, Z value for 68. Very good. Okay, Parth is asking, when we divide, a new curve is bell 1? Very good question, Parth. Very good question. All right. Okay. Yes, yes. I'm just coming on to that part. All right. First of all, guys, did you all understand how to calculate the Z score? Yes. Great. Now, guys, what I have basically done till now is standardized all these values which were in inches earlier. Okay. So my initial value was in inches. I subtracted mean value from it, which was again in inches, right? So I did inches minus inches. So the units are gone. Yeah. And it has become standard in nature. All right. Now, guys, sorry, inch minus inch, divide by inch. Okay. So no units. Thanks a lot, Deepak, for that. Yep. So what I'm saying is we did inches minus inches and we divided by inches. So the units are gone. Now, guys, the beauty of Z statistics is that even after you have converted all these values into a Z score, okay, the ultimate distribution also remains a bell curve. Okay. Rather than having a value of 70, 71, 72, so on and so forth, you'll have values like 0, 0.5, 1, 1.5, 2, 2.5, so on and so forth. Is this clear to everybody? Yep. Perfect. Now guys, if I'll do a similar thing for weight also. Exactly, Deepak. That's what we do. So guys, if I do the similar thing for the weight also, what will my x-axis value will start showing then? 0, 1.1, 2, 3, so on and so forth, and negative values on this side. Can I say that? Yes. And will this have any sort of units associated with it? Yes, Parth. The mean will always be 0. So guys, now what has happened is that you have converted height, which was in inches, into z-score, weight, which was in inches, into z-score. Now both your variables are now what? Z-score or Z-statistics. Can these now be compared? Yes? Perfect. So guys, the point which I was trying to make is that whenever there is a requirement for doing some sort of variable comparison which follows normal distribution, you can convert those variables into z-scores and then compare these two variables. Okay? Okay, there are a few questions now. Himanshu is saying, but I have a question. Okay, Himanshu, go ahead and ask your question, please. Ashima is saying z-score used only for comparing two ranges. Uh, Primarily Ashima, but there are other applications of z-score also. Okay. Uh, Sometimes what happens is, okay, sometimes what happens is Ashima that, when you have a huge range of values, let's say starting from 0 to 1 lakh, and you want to negate the impact of that particular variable, okay, uh, you convert those values into z-scores and start using those variables. We'll get to see that when we will read around clustering. Okay, so just hold on to that question, Ashima. When we will learn clustering is where I'll show you another application of z-score. Okay, Ashima, is that fine? Yeah. Ashima, I'll just request that please ask the same question when I'll be teaching clustering. Okay, that point of time I'll be able to show you the application. All right. Himanshu is saying, how can we have a bell curve if mean is 0, as most of the value range in and around? Oh, okay, okay, okay. No, no, I think Himanshu, you're mistaken. Let me just explain that. Himanshu, the mean value is 0 means that on x-axis this 70 will get replaced by 0. Okay, the mean value is not 0. The z value which we have calculated for the mean is equal to 0. Yeah, exactly, Deepak. Thanks a lot. Himanshu, does this make sense? I'm not saying that the mean has become 0. I've just transformed mean into a z score of 0. Himanshu, are you clear? Okay, so Himanshu, assume it this way. Earlier, I had a height of 70 okay, which had certain value of probability, you know. So between 68 to 72, I had probability curve, something like that. It's just that rather than calling it 68 to 72, now I'm calling -1 to 1, but the curve still remains the same. Does this make sense, Himanshu? No? Okay. So what exactly is confusing you? Himanshu, it is just another representation of your variable. I'm just changing the values on the x-axis. Rather than calling them 70, 71, 72, I'm calling them 0, 1, 2, so on and so forth. Exactly. That's how -1, 0, 1 makes a bell curve. Yep. Exactly, Deepak. Yeah, you're right. You're right. Himanshu, is this clear? Yes. Thanks a lot, Deepak. That was really great input. Helped me understand. Thanks a lot for that. Guys, is everybody clear about the Z statistic? Perfect. So guys, let's do one thing. Uh, it's 9 o'clock right now. Let's take a quick 15 minutes break and we'll be back at 9:15. Okay. And at that point of time, we'll start with uh, hypothesis testing or inferential statistics. Okay, we'll start with inferential statistics and hypothesis testing at that point of time. All right. Great, guys. Let's catch up in 15 minutes. Hey guys, welcome back. I'm so sorry. I think I got a little late. Is everybody around? Great, great, perfect. All right. So, guys, I hope the concepts of normal distribution are clear to everybody. Okay. So, guys, what we will do now is we will get into inferential statistics. Okay. Now, anybody has understanding of what is inferential statistics? Can you guys guess what inferential statistics is? We very briefly talked about it in the last lecture. Soumya says which infers. Oh yeah, that's a wonderful definition, Soumya. Amazing. But what infers? What does it infer? What does it infer? Guys, any guesses? You remember we very briefly touched upon inferential statistics in the first session. Kirti says how dispersed the data is. No, 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 no. Kirti, that was measures of dispersion. That was measures of dispersion. Okay, let me give a hint. Okay, Dilip says it about population talks about population by taking samples. Kind of. Infers information about population basis sample. Exactly. Exactly, guys. Absolutely correct. So, guys, whenever we okay, so you remember we said in the first class that we never work with populations, we always work with samples, right? But our ultimate aim is to find out details about the population, right? That's what our goal is. If I'll tell you to tell me the average height of of males in US, and you pick up 100 males of US and say that the average of these 100 is 70, I'll probably not be convinced because the average across US can be 72 or 73, right? Isn't it, guys? So whenever using sample statistics like mean and standard deviation, you try and infer something about the population parameter, you call this study as inferential study. Okay, let me repeat. When using sample statistics, you try and infer the values of population parameter. This whole process or whole study is known as inferential statistics. Is the definition clear to everybody? Yep. Kirti, Parth, Ramesh. Yeah, great, perfect. All right. Now, there are two parts to inferential statistics. Okay. The two parts are, one is estimation. The other is hypothesis testing. Deepak, I didn't understand what you're trying to say by these dashes. Anything you want to ask in specific? Ah, okay, okay. All right. So guys, as I mentioned, that there are two parts to inferential statistics. One is estimation. The other is hypothesis testing. Okay. Now let's look at estimation and hypothesis testing one after the other. Let's first talk about estimation. Okay. Estimation, as the name suggests, is nothing but estimating the population parameter given you have sample statistics. So if I am being given sample mean, using this sample mean, I will estimate population mean. Okay, so what I'm doing is using sample mean, I'm estimating population mean. Does this make sense, guys? That's what estimation is all about. Okay, yeah, all right. Now let's talk about a small concept in estimation, that is accuracy versus precision. Guys, can somebody tell me what is the difference between accuracy and precision? Okay, let me give an example on this. All right, all right. Let me give an example. Guys, can all of you guess that what is my monthly take home salary? Guess my monthly take home salary. Make any guesses. So Himanshu says 1 lakh. What else? Quickly, 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 guys. Parth says 2 lakhs. Dilip says 1 lakh. Okay. One more. Kirti says 2 lakhs. Okay. All right. So we've got 1 lakh and we've got 2 lakhs. All right. So guys, Ramesh, thanks a lot for that. If I would have got that, it would have been wonderful. All right. So let's stick to this. Okay. So guys, the answers which you have just given me are very precise. When you say 1 lakh, it's a very precise answer, just absolute value 1 lakh. When you say 2 lakh, it's a very precise answer, you know. But is this accurate? With what confidence are you saying 1 lakh? How confident are you when you said 1 lakh? Okay. Vis-a-vis, let's say if you would have given me an answer like this, 90,000 to 1.3 lakhs. If you would have given me this answer, where do you think? Okay, so let's take two examples. One of you answered saying 1 lakh. The other one said 90K to 1.3 lakhs. Now, where do you think the precision is high out of these two, A and B? Where do you think is the precision high? Guys, I think Ashima is right. Precision is high in A. 1 lakh is a more precise answer as compared to 90K to 1.3. Here you're talking about a range. Here you're talking about an absolute value. So whenever you talk about an absolute value kind of thing, you will have a high precision. Whereas when you're talking about a range, your precision is low. But the accuracy will be higher over here. Because you're giving a range of values, there is a higher probability for you to be accurate as compared to this. Guys, is this making sense? Yes? Is everybody convinced with this? Great. So guys, the point which I was trying to make is that if you are being given a sample mean and you're being asked to estimate population mean, will you estimate a range of value or an absolute value? Range of values, right? Because our focus is always to be more accurate as compared to be more precise. Okay, so it is kind of a trade-off. If let's say I'm being given a sample height of US male being 70 inches, you can't go into the range of 10 inches to 100 inches just to be accurate, because this will not make sense. But you can't even say 68 inches as the average height of population just to be more precise and very low on accuracy. So there is a trade-off. You have to either, you have to come up with an answer which is okay on accuracy and okay on precision. So probably an answer like, 67 to 73, which from the precision standpoint also makes sense, and the accuracy standpoint also might make sense. Okay, guys, does that make sense? Yeah. So guys, just to summarize on whatever I have said till now, whenever we try and estimate a population parameter using a sample statistic, we have to make sure that we try and give an answer which is precise but at the same time also accurate. Okay, Parth is asking a question that is there any way to get accurate precise estimate for population? Parth, generally what happens is that whenever you're being asked a question by business, they always tell you that how accurate they want to be. So they'll tell you that they want to be 90% accurate or 95% accurate or 99% accurate, basis which you can find out the range of values. Okay, that's how generally business asks questions. Okay, great. All right. Okay, so the first thing which we learned about estimation is that there has to be a trade-off between accuracy and precision. Now, the second thing which we have to learn is that how should we really do this calculation? Okay, guys, the calculation is very simple and straightforward. And that is done basis a theorem, which we call as central limit theorem. Has anybody heard of this particular theorem? I think Deepak must have. Deepak, have you heard about it? No? Okay, not a problem. All right. So guys, what central limit theorem says is as follows. No matter what the population distribution is, it doesn't matter that whatever distribution the population follows, but the distribution followed by multiple samples taken from the population, the distribution followed by means of multiple samples taken from population will always be normal. Okay, so guys, just to give it explain it with an example. Let's say that your population distribution is something like this. Does this look normal? No, right? What central limit theorem says is that if you'll take multiple samples out of this population, calculate the mean for each of these samples, and draw a distribution for these means. So this is mean 1, mean 2, mean 3, mean 4, mean 5. If you'll draw the distribution of these mean values, this distribution will always be normal. Yeah, Parth, I'll just come on to that. But first of all, did you understand what I'm trying to say? The central limit theorem says that no matter what your population distribution is, the distribution followed by means of multiple samples taken from the population will always be normal. Is this clear, guys? First of all, is the statement clear? Yes? Okay. Parth, I'll come on to your question, but let me just explain this concept a little more, okay? Yeah, Deepak, ask me, you were asking something. No, not necessary. I'll explain it to you. Deepak, I'll explain it to you. Let's assume that our population was normally distributed. Okay, though doesn't look like normal distribution, but assume it is normal. Now guys, don't you think I can take a sample like this? My sample which I have taken could be something like this. This smaller curve over here. Can it be like this? Yes. What will be the mean of this one? Somewhere here. What if my sample is something like this? The mean will be somewhere here. What if the sample is something like this? The mean is somewhere here. So on and so forth. Yes. So Parth, if this is the overall population, are these not subset of the population? These are the subsets of population, right? This curve which I have shown is nothing but a population which lies within this range of values. So is this not a subset of population? It is, right? Yeah. Okay. So guys, let's say if this is the population mean, and these are the means of each of the samples I have taken, M1, M2, M3, M4, M5, M6, M7, M8, M9, and M10. Now tell me, if I'll take the mean of all these means, mean of all the means, will they coincide with the population mean or not? Theoretically. It should, right? I can say that, right? If I'm taking enough number of samples so that they cover the entire range of population, the means of each of these samples will coincide with the population mean. Is everybody clear on that? Yes? Perfect. Now tell me one more thing. if this was my whole population, which had some standard deviation S1, and if I draw the distribution of means of the sample, will this distribution have a standard deviation S2 less than S1 or greater than S1? Theoretically, logically think and tell me. What I'm asking is that let's say the standard deviation of the population was S1. For each of these samples, I took out the mean M1 to M10. Will the standard deviation of the distribution of these means, will they have a standard deviation lesser than population standard deviation or more? Okay, so Deepak is saying it should be equal. Himanshu is also saying equal. Soumya is also saying equal. Srinivas says lesser. Deepak is saying S1 should be greater than S2. Okay. All right. Okay. So let me explain this with a working example. Guys, if I'll talk about male population of US, okay, it will include everybody starting from kids to elders, right? So there is a huge deviation out here from kids to elders. Yes. But now let's say I start picking up samples out of this population. So let's say I have a small population of kids, small population of teenagers, youngsters, elders, so on and so forth. Now, obviously, the averages will not be from minimum to maximum value. So if I'll pick up the, if I'll pick up the population of kids, and let's say they are from this height to this height, my mean will become a little closer, not really equal to the minimum value, right? It'll be a little greater than minimum value. Similarly for elders, if this is the range of height, the average will be a little lesser than the maximum value. Yes. Similarly, for other range of populations, the average will keep on decreasing down, right? So don't you think that the dispersion has become lesser as compared to the actual population? Yes. Can I say that, guys? So guys, basically, when you draw the distribution for sample means, yes, Ashima, I customize the sample just to give you an example. Even if I'll not customize it, and let's say my sample spreads over this range altogether, don't you think that the average will still become lesser? Okay, guys, I think it is not really clear to everybody. A little disconnect, I understand, but let's take it on the face value that a distribution of sample means will have a standard deviation which will always be lesser than the distribution of population with standard deviation S1. And let's say there the sample deviation is S2. So the distribution of sample means will have standard deviation lesser than distribution of population. Okay. Guys, is this clear or are you guys confused? Okay. So guys, finally, in order to do, all right, Ashima wants me to give another try. Ashima, let's say this is your population distribution. Okay, this line. This is the minimum value. This is the maximum value. What I'm saying is that if you'll start taking out samples, let's say you took out one sample like this, the average will be somewhere here. You took another sample out, let's say like this, the average will be somewhere here. You took another sample out, which is somewhere here. The average will be somewhere here. You took another sample like this. The average will be somewhere here. Now I'm not customizing, okay? I'm doing random plots for you. Yeah. Now tell me, if I have these 5 means and I plot a normal distribution for these means, will the dispersion of these 5 can ever be more than the dispersion of population? Got it? It will always be lesser than the population, right? Is everybody clear on this? Himanshu, never be equal also. I'll tell you why. For the population, the dispersion is driven by extreme values, minimum and maximum. Exactly. The minimum value of population will always be lesser than the minimum value of the sample, whichever sample you pick up. Similarly, the maximum value of the population will always be greater than the maximum value of a sample, whichever you will pick up. So their dispersion will always be lesser. The sample dispersion will always be lesser than the population dispersion. Everybody clear? Yes? Great. So guys, okay, so we were talking about estimation, right? But so we do estimation on the basis of this distribution of sample means. Okay. So as we saw that this distribution of sample means, the mean of this distribution of sample mean coincides with the mean of population, and its standard deviation is equal to population standard deviation divided by square root of sample size. Okay, so I'm bringing in this new formula now, guys. What I'm saying is, as we saw that the distribution of sample means will have a mean which will always coincide with the mean of the population. Yeah, we saw that, right? When we drew this diagram, we said if this is the population mean and if these are the samples with the means like these lines, so when we take these lines, which are the means of each of these samples, their mean will coincide with the population mean. We said that, right? And the standard deviation of these sample means is less than population standard deviation, and that is equal to population standard deviation by square root of sample size. Is everybody clear till this point? Guys, if you have any confusion, please ask. Yeah, Ashim, I'll come on to that. I'll come on to that. Is everybody clear till this point, guys? Yep. Okay. So guys, now let's say I'm being given a sample. The sample has total observations, which are, let's say 100 observations in the sample. The mean of the sample is 40 and the standard deviation is, let's say, 20. Okay. And I'm being asked to find out the population mean with the confidence level of 99%. So I can use this mean as the, okay, so what I'm saying is that I've got a sample mean now, which is somewhere here. The standard deviation is 20. The sample size is 100. And I have to calculate the population mean with 99% confidence. Does this question sounds a little familiar of what we did before the break? I'm being given mean. I've got the standard deviation. I've got the confidence range, and I'm being asked to calculate the range of values in which the population mean lies. Yeah, norm inverse. Absolutely correct, guys. Just that you will not use standard deviation as it is. You will use standard deviation as standard deviation of the sample divided by square root of sample size, that was 100 in our case. So this is the standard deviation which you will use. Does this make sense? Yeah. So if I have a sample of size 100, mean 40 and standard deviation 20, and if I have to find out the 99% confidence interval, so I'll use the mean as it is. I'll use the standard deviation of sample mean. Okay. Exactly, Srinivas. Yeah, absolutely correct. Standard deviation as, 20 divided by square root of sample size. That's equal to 2. And then I'll use norm inverse. That is equal to, guys, norm inverse equal to 40, comma, sorry, 99% confidence, right? 0.99, comma, 40, comma, 2. Guys, does this make sense to everybody? Okay. Now, whatever I have taught is absolutely perfect except one thing. Except one thing. And let me tell you what that one thing is. Guys, when we did the calculations in normal distribution, we used norm inverse for certain level, for the probability below certain level of value, right? That's what we did, right? Everybody remembers that? Yes? But when we do estimation of population, when we do estimation of population parameter, we always consider no, I've not considered 40 as mean for population part. I'm calculating means of population. I'm calculating means for the population. 40 was the sample mean is what I said. Okay. So guys, when we do the calculation for estimation of population parameter, we always look for probability around the mean. So when I'm saying 99% confident, I don't consider 99% below certain value. I consider 99% within the range of certain values. So this is the 99% I'm talking about, not the whole thing below this level as 99%. Does this make sense? Okay, so there is a small difference in calculation. In my normal distribution calculation, what I did, I tried finding out a level below certain value, and this total area I assume to be 99%. But when we do population estimation, we don't consider value before certain value. We always consider a range of values around the sample mean. Okay. Is everybody clear on that? Okay, great. So guys, tell me, if my sample mean is 40, sample standard deviation is 20, sample size is equal to 100, and I have to be 99% confident for, predicting the population mean. So this is my sample mean, that's 40. And I want to be 99% confident. That means I have to find out the range of values between this value and this value. And this whole area is 99%. Then what will be the value of this lower limit and upper limit? Can somebody tell me? What will be the range of these values? So Srinivas says 20 to 60. Srinivas, do we consider the standard deviation straight away, or should we use standard deviation by square root of sample size? Parth, for you also, should we consider standard deviation straight away, or should we use standard deviation by square root of? Yeah, so quickly do your calculations again and tell me the answer. So Deepak says 34 to 46. Okay. Srinivas says 38 to 42. Guys, I'm talking about being 99% confident. 99% is how many standard deviations away? Yeah. 3. Ashima, is the answer clear to you? Yes. What about others? Ramesh? So guys, when I have to be 99% confident, my mean is 40. My standard deviation turns out to be 2. 99% is 3 standard deviations here and there, which is 40 minus 6, that's 34. 40 plus 6, that's 46. So 34 to 46 is the range in which my population mean will be. Okay, does this make sense to everybody? No, Kirti, this is the estimate which we have got. As I told you that we always look at the range of values. So the population estimation is 34 to 46. And we always use 40 as the sample mean to calculate these range of values. Okay. Okay, so guys, let's do a practical example, and I think that will make things a lot more easier for all of us. Okay, let's do that. Okay, let's look at question number 2. Upon collecting a sample of 81 packets of biscuits, what is the sample size, guys? What is the sample size here? 81. It was found that on an average 13.7 packets were not sealed properly. Okay, so guys, I have got a sample of 81 packets. On an average, it was found that 13.7 packets were not sealed properly. So what does the sample mean? What does the sample mean? 13.7. Perfect. With a standard deviation of 2.8 packet. So what is the sample standard deviation? 2.8. Yeah. Is everybody clear till this point? Kirti, Parth, Srinivas, yeah, okay. So guys, okay, now what the question says is, how many biscuit packets will not be sealed properly for a complete batch of biscuits with 90% confidence? So we are being given a sample mean. We have to find out population mean. Is the question clear? Guys, is the question clear to everybody? Guys, any question, any confusions, I'm happy to resolve. Guys, any questions? Or is everybody clear till this point? Good. Okay. So guys, so we have been given sample mean, sample standard deviation, and sample size. What is the value of standard deviation which we'll use for our calculation? Quickly tell me. 0.311 is what Parth is saying. 0.3 is what Deepak is saying. What about others? Absolutely. Ashima, why 3? The sample size is 81. So it'll be 2.8 divided by 9, right? Yeah. That is 0.311. So this is the updated standard deviation value which we will use. All right. Now, what is the confidence interval I'm looking at? 90%, right? Okay, so let's see what value we get. So guys, this is my sample mean 13.7. I want to be 90% confident, 90% confident around this mean, right? So I have to find out the value of this and the value of this value. So I have to find out these two values to define the range, right? Now tell me, if this whole area is 90%, how much is this area? 0.45. Everybody agrees with me on that? Okay. If this is 0.45, how much is this area? How much is this area? 0.05. Everybody agrees with me on that? Yeah. So it means if in my norm inverse, I'll give the probability as 0.05, then I'll get this value. Can I say that? Yes. So quickly put in the value in norm inverse as 0.05 with this sample mean and this standard deviation, and tell me what is the value. Okay. So Himanshu has calculated and he's saying 13.1. Is that what everybody is getting? Deepak is getting 13.20654. Okay, let me calculate that. 13.18 is what everybody is getting. So I'm assuming that that is correct. Okay. All right. Now, so you've got the lower limit 13.18. Now tell me one thing. This is the upper limit which we have to calculate, right? What is the total area under this curve behind this line, behind the mean, behind the mean? Only this much area. 0.5. And what is this value? 0.45. So what is the total value behind this particular curve, this particular line? 0.95, right? So now if I'll put 0.95 in my norm inverse, I'll get the range value for this particular line. Will I get that? So Ramesh has calculated this as 14.21. Is everybody getting that? Perfect. So can I say that if in my sample of 81 packets, on an average 13.7 packets were not tagged properly, in my whole population there will be 13.1 to 14.2 packets which will not be sealed properly, and I am 90% confident on that? Can I say that? Is everybody clear on this? Guys, any questions? Okay, if it looks like clear, let's just do another question quickly for everybody's confidence. Yeah. Okay, let's do one quick question. Let's look at question number 3. And let me just write down all the parameters here so that nobody gets confused. And I want all of you to resolve this answer, come up with the answer for this one. Okay. Let's say that Ambrish is a stock market broker and wants to find out the time between the placement and execution of market order. Okay. Ambrish sampled 45 orders. So what's the sample size? 45. And found that the average time taken was 24.3 minutes. So the mean is 24.3, with the standard deviation being 3.2 minutes. Okay. So let's say Amrish is a stockbroker. He wants to find out that whenever he places an order to buy a stock, after how much time does the stock gets bought? Okay, so there is a placement of order and the execution of order. What is the difference between these two? So when he looked at the sample of 45 orders, he found out that on an average, 24.3 minutes is what is taken for the order execution, with a standard deviation of 3.2 minutes. Okay. Now let's do one thing. Let's change the sample size to 49 to make the calculations simpler. All right. Now guys, help Amrish to construct a confidence interval for mean time to order execution with 80% confidence. Okay. So are you guys doing it? Himanshu, tell me both the sides of the range. Tell me both sides of the range, guys. 80% confidence is what we are looking at. I'm just drawing the diagram for all of you so that you can calculate the right answers. The mean is 24.3. Standard deviation, you guys have to calculate using sample size and standard deviation. We're talking about 80% confidence. So this is 80%. Himanshu says 48.6 to 49.3. Himanshu, I think you have mistakenly taken 49 as the average. The average time is 24.3. Calculate using that. Deepak, you have to give me the range of values. This range and this range. The average is 24.3. So just keep thinking that your range has to be in and around 24.3. It can't be 0.45. It has to be in and around 24.3. Oh, okay. 0.5 is the standard deviation. All right. Perfect. Quickly, guys. Tell me both the values of the range. Ashima says 23.65 is the lower bound. Okay. Himanshu says 23.7 and Himanshu's upper bound is 24.69. All right. What about others? 23.7 is the lower bound is what Deepak is saying. All right. All right. Okay. Okay. 24.9 is the upper bound for Ashima. All right. Kirti is 24.69 as that of Himanshu. Deepak 24.88. Okay, minor differences. That's okay. I'll check that. Okay, so guys, let me do this calculation, all right? So guys, my sample size was 49, okay? So the calculated standard deviation for me is equal to 3.2 divided by square root of 49. That's equal to 0.457, okay? Now, if this range is 80%, then this half is 40%. The shaded half below the mean is 40%. And what I'm left with is 10% of the percentage here. So I'll use norm inverse for 10% first. 0.1, comma mean is 24.3. Standard deviation is equal to this. So this will give me my lower bound, that is 23.714. Perfect. Similarly, if the value between the upper range and the mean is 40%, rest all is 0.5, so together is 0.9. I'll say equal to norm inverse 0.9 comma 24.3 comma standard deviation of this much, and I'll get 24.885. So guys, the correct answer is what Ashima has just given on the type, 23.71 to 24.88. Guys, everybody clear now? Oh, Kirti is confused. What happened, Kirti? Tell me. Ask. What happened? Okay. Himanshu is asking why 0.1 in lower limit calculation, why not 0.2? Himanshu, as I said, that when we estimate population parameter using sample, we consider the probability around the sample mean. So the sample mean is here, 80% around the sample mean. So what I'm saying is that this upper range and this lower range, between this, the probability is 80%. Are you clear till this point? Sure. Kirti, I'm just explaining that. Okay. First of all, guys, tell me one thing. Is this clear that this 80% which we are looking at is around the sample mean? Is this clear? Kirti, Himanshu? This 80% is around the sample mean, yes? Now, if this 80% is around the sample mean, and we know that normal distribution is a symmetric distribution, what will be the area which I'm just highlighting right now? How much is this area, Kirti, Himanshu? 40% or 0.4 can I say? Himanshu? Yeah, good. And what is this total probability below the mean, guys? 0.5. So guys, if this is 0.4 and the whole area is 0.5, then how much is the left one? Kirti? 0.1. Yeah. So it means this lower range, below this lower range, the total probability is 0.1. Can I say that? Kirti, can I say that below this lower range, the probability is 0.1? Great. Now Ramesh is saying, can you explain one more time calculation? I'm getting it wrong. Ramesh, are you clear till this point where we are saying that the lower limit is zero point 0.1 probability? Are you clear till this point? Ramesh? Okay. Ramesh, the mean of sample is 24.3, right? Is this clear? The mean of sample is 24.3. Are you clear on the 80% probability being this much shaded area which I've just done? Are you clear that we have to find out this range of values? Are you clear that the lower limit can be found out using the probability value of 0.1? Okay. So if the lower limit probability value is 0.1, and if I'll apply the norm inverse formula, norm inverse probability is 0.1 and mean is sample mean is 24.3. Yes. And the standard deviation is the new standard deviation we calculated, 0.545743. So if you'll key in all these values, you'll get the lower bound as 23.71. Ramesh, does this make sense? Okay. Soumya, remember I said the standard deviation has to be calculated as standard deviation of sample divided by square root of sample size. Remember that, Soumya? Yeah, great. So guys, is this clear to everybody? Everybody? Great. Guys, what I want you to do is, I want you to practice these 3 questions again when you go back home. Okay? Any doubts which you get, mail them across on contact@equiskill.com. Okay? All right, everybody? Yeah, guys, these questions will be uploaded on the LMS itself. You can pick them up from there. Okay? I'm not sure, Kirti, if they're already there on the LMS, but they will be there, don't worry. All right? Okay, and guys, if you get any kind of a problem, any kind of an issue or any kind of a concern, just mail it across to contact@equiskill and I'll respond back. Okay? Okay. So guys, now that we are done with estimation, let's have a quick understanding on what hypothesis testing is. Okay. We will probably do the example in the next class. We'll do the example in the next class, but I'll explain the concept of hypothesis testing. Okay. Now, can somebody tell me the English meaning of a hypothesis? What is hypothesis? Very good, Deepak. Very good, Soumya. The English meaning of hypothesis is assumption. Okay. And when I say hypothesis testing, what does that mean? That you are testing an assumption. Does this make sense? Yep. Exactly, Parth. We are checking the correctness of the assumption. Now, assumption about what? Assumption on what? No, Kirti, not about the estimation. We assume something about the population mean. We assume something about the population mean, and then we try and test if our assumption is correct or not. Okay, guys, does this make sense? Okay, so the assumption which we have, yeah, Deepak, I'll give an example. The assumption which we make is called as null hypothesis, represented by H naught. Okay, and the alternate to that assumption is called as alternate hypothesis, that is HA. Okay, for example, let's say I'm a bulb manufacturer. Okay, and I claim that on an average, each of my bulb runs for at least 100 hours. So what is the assumption which I have, guys? That the bulb runs for 100 hours. So in this case, my null hypothesis is that the average life of bulb is equal to 100 hours. Okay, and the alternate hypothesis is that the average life of bulb is not equal to 100 hours. Deepak, is this clear? Everybody, did you understand how do we formulate the hypothesis? Yes? Great, great. Now, if I have formulated the null hypothesis and the alternate hypothesis, how will I test these hypotheses, guys? Obviously, I don't have population data, right? So how will I test my null and alternate hypothesis? Using what data? Exactly. Using sample data. Okay. Now in sample data, what all do I want? The mean, the standard deviation, and the sample size. Yeah. If I'll have these three, then I'll be able to calculate that what my population mean should be. Okay. And basis that, I can conclude that whether my assumption is right or wrong. Does this make sense? Yes. If I'll have the values of sample data, I'll be able to find out the range of values in which the population mean lies. Yes, H naught is population mean path. Absolutely correct. I'll be able to find out the range of values in which my population mean lies, and basis that I'll be able to say that whether my null hypothesis and the alternate hypothesis is wrong or right. Okay? Is everybody clear on that? Any questions, anybody? Yeah? So should we take it up in the next class? Is that okay? Yep. Guys, what I'll do now is I'll share with all of you the link to today's class feedback. I will request all of you to start filling in your feedbacks. And in the meanwhile, I'll be open to any sort of questions which you guys have. You want me to explain something again? You want me to talk about something again? I can do that right now. But I would request all of you to please fill in the feedback for today's class. And I'm open to any sort of questions which you might have. Guys, please let me know once you have filled in the feedback. Please confirm it into the chat box and ask any questions which you might have. Guys, please confirm once you have filled in the feedback. Thanks a lot, Deepak. Thanks a lot, Kirti. I hope you guys, got some kind of a learning from today's class and your concepts of statistics have become a little more clearer. Yep. Guys, any sort of confusions you have, please ask. I'm happy to answer. Anytime, Kirti, that's my job. Ashima, there is a link which I have provided into the chat box. You have to click on that particular link. Let me still paste it again. Yeah, Deepak, absolutely. That's not a problem. Guys, also while filling in the feedback, please mention any expectations which you guys have and I'll try and meet them. Goodbye, Deepak. Have a good night. Take care. Thanks a lot, Parth. Thanks a lot for filling in the feedback. Thanks a lot, Ramesh. Yeah, Parth, I'll get back to you on all your queries. That's not a problem. Thanks a lot, Kirti. Have a good night. See you. Himanshu, I hope you have filled in the feedback. Thanks a lot. Thank you. Thanks a lot, Srinivas. I hope you enjoyed the class and there was some kind of a value add which I could do to your learning. See you all in the next class, guys. See you all. Guys, I'm still waiting for all of you to confirm if you have filled in the feedback.